Nature has always been a source of inspiration for mathematics. In fact, we can say we live our lives surrounded by mathematics. I'm David Crombecque, Professor of Mathematics at UAC Dornsife College of Letters, Arts and Sciences. The Greek philosopher and mathematician Pythagoras might have said that all things are numbers, and that mathematics may claim to be the most original creation of the human spirit. And indeed, one can say that mathematics is a human construct that seeks to understand and explain the world surrounding us. Named after the Italian medieval mathematician Leonardo Fibonacci, the Fibonacci sequence is probably the most famous sequence of numbers. Its first two terms are both 1 and 1, and each subsequent number in the sequence is obtained by adding the two previous numbers. Therefore, after 1 and 1, the next number is 2, which is 1 plus 1, the next number is 3, which is 2 plus 1, the next number is 5, and 8, and so on. While some people say that the numbers in the sequence appear frequently in nature, such as the number of spirals in a sunflower head or a pineapple, it is actually the ratio of the terms of the Fibonacci sequence that is mathematically interesting, as it relates to the golden number, also called the golden ratio, which is a number close to 1.61. And for instance, the chambers of a Nautilus shell increase in size with a ratio close to the golden number. A fractal could be described as a geometric shape that has a pattern repeating itself at smaller and smaller scale. This means that if you zoom in and out, the same shape is visible throughout. In nature, exquisite fractals can be observed in fern leaves, eroded coastlines, or, with the help of a microscope, in a snowflake. The study of fractals has been a serious topic of research in many different branches of mathematics, such as analysis, geometry, and dynamical systems. The Mandelbrot set, named after mathematicians Benoit Mandelbrot, is probably the most famous representation of a mathematical fractal. Although we can't see it with our bare eyes, DNA is the ultimate way for nature to encode information in every living cell. Visually, one can think of DNA as a giant molecule composed of two strands that are tangled in a very complicated way. Knot theory, a subfield of topology, itself a branch of mathematics, seeks to differentiate knots. Many of you may know about the square knot or the trefoil knot, but what makes them mathematically different? Knot theory was originally thought as a way of understanding elements in chemistry, such as hydrogen, oxygen, and so on. But that was until we discovered atoms. But knot theory is nowadays used to help understand how some enzymes change the way DNA is tangled, thus altering its chemical function. Visible to the human eye or not, many natural phenomena were the catalyst for mathematical advances and discoveries. So, whenever you find yourself admiring the beauty of nature, be careful, you might stumble on a math problem.